about 1:03, do some introductions, and then get into the webinar presentation. We will have the Q&A open. I believe it's already open. So if you have any questions to get started, feel free to put in them. Put questions in the Q&A section, and we will answer those throughout as they're needed. And if we don't have time while we're going through the presentation, we have about 15 minutes reserved at the end to get to questions. So I thank everybody for joining the webinar. Just bear with us for another 2 minutes just to make sure we let all the attendees, if anybody's running late, coming from another meeting, to join. Just giving everybody 1 more minute to join here. It's now 1:03, so we can go ahead and get started. I appreciate everybody joining our Local Law 97 webinar. My name is Eric O'Neill. I'm the Director of HVAC at Tagup. We'll go through a little bit more in-depth introductions here in a minute. And I'll actually turn it over to Jay first to introduce himself from Ecosave, and then Matt will follow up. So Jay, go ahead and take it over, give a little bit of background on yourself and Ecosave.
Hi, everyone. I'm Jay Handmer. I'm the Services Director at Ecosave, and I work on developing projects, quantifying emissions reduction, helping with LO 97, and helping our customers deliver energy reduction goals.
Great, thanks, Jay. My name is Matt McHugh. I am the account executive for C-Power. Been working at C-Power now for about 4 years. We are the patriarch of demand response, serving all deregulated markets nationwide. What I love about demand response is it provides revenue to building owners to pay for decarbonization measures. I'll get more into that during my talk. Prior to coming on to C-Power, I was a director of sales and marketing for New York City's largest sustainability firm. And I started there in 2010. And what really kind of had the big boon for our company back then was the Greener Greater Building Plan. So that was the predecessor to Local Law 97. So I know these laws very well and really know the decarbonization frameworks very well, and really look forward to sharing that knowledge with you today.
Thank you, Jay. Thank you, Matt. So as I said earlier, my name is Eric O'Neill. I'm the Director of HVAC at Tagup. We are an industrial AI company, so we use data from HVAC equipment to recommend controls that are going to lead to lower energy consumption, lower carbon emissions. We combine the equipment data with utility rates as well as weather data, and that's how we look to retro commission HVAC equipment to operate at the lowest potential costs and energy consumption. So today we're going to be going over a little bit of background on Local Law 97 for those that are not as familiar with it. We'll then talk about some strategies of how to avoid the fines. Matt's going to go through C-Power's demand response program. I'll go through our HVAC optimization product. Jay will go through Ecosave. We all work as partners, which is why we're on this webinar together. We find that some sites need all three of us. Some sites might just need one of us. So, we're more than willing to talk after the webinar with any sites that you'd like us to look at, and can let you know where we all can fit in to help you avoid local law 97 fines. So local law 97 has been something that's been talked about and put in legislation a while ago. This is the first year, 2024, where buildings will have to start tracking emissions. The buildings that are covered fall into a couple categories, whether they're buildings that exceed 25,000 square feet, 2 or more buildings that together exceed 50,000 square feet, or 2 or more condominiums that are governed by the same board that exceed 50,000 square feet together. Local Law 97 is used by New York City to help meet their net zero goal of 2050. So this is one of the first strong initiatives following up on some of the ones that Matt was talking about earlier. And really, we see this as a way that building owners are going to have to start paying fines unless they meet these requirements. So the fines there's a few different types of fines. The first one is the failure to report. So this is where buildings that don't report their emissions and energy consumption will be fined 50 cents per square foot per month. So it can get pretty large fines pretty quickly. If the emissions exceed the limit, that's over the building's limit, it will be $268 per metric ton that any of those emissions that exceed wherever the building limit's set at. And any instances of false reporting will be fined $500,000. So the New York City sustainability, it talks about the reports. So for any buildings that exceed the annual carbon emissions limit will be liable for a civil penalty. And so far, the estimate is about 20 to 25% of buildings will exceed their emission limits in 2024. The limits become much more aggressive in 2030. And that's where the city council believes about 80% of buildings, if no action is taken, will start being fined in 2030. A simple resource that the New York City Accelerator provides to estimate potential fines. You can type in your address at this link. You can and it will tell you about the different fines that you'll be eligible for. They also provide a little bit of information that if you reduce your power consumption by 10%, how much of the fines you'll avoid. So it's a good resource if you want somewhere to get started, just to give you an idea. In terms of some proactive steps you can start taking now. One is to conduct an energy audit. So this is something Jay and his team at Ecosave can help you with, where they go through understanding where your building is consuming energy, what the respective emissions are, and start targeting certain areas, whether it's HVAC systems, lighting, any other mechanical systems within the building that are consuming a lot of energy, and start putting together a plan to reduce energy consumption and related carbon emissions. Some of those steps, as I said, is replacing older inefficient equipment with new equipment. Sometimes there isn't necessarily funding available within the organization for that. So there are ways to implement energy conservation measures, gain the most out of your existing equipment so that you can lower your emissions. One way is implementing Tagup solution for HVAC optimization. And the nice thing about these different building upgrades is New York City has a large number of organizations that are incentivizing different utility customers or just general organizations that operate in the city to implement energy tracking tools or energy reporting tools, something similar to Ecosave Watch that will track your energy consumption across sites, as well as replacing inefficient equipment. There are energy service agreements, which is another thing that Ecosave can offer, where there can be a cash flow positive agreement to replace equipment in the building and start seeing not only savings in energy consumption but reductions in carbon emissions. And then lastly, and this will be where Matt takes over in a minute here, there's demand response programs. So these are where you can shed some of the load and sell it back to the city. Be compensated for that, and that can help pay for different upgrades or programs that you want to take place to help lower energy consumption. This is a list of local law 97 incentives that Jay and the Ecosave team put together. Jay, is there anything you want to add for color to this?
No, I would just say that the New York utility and state government environment offers a huge array of different incentive programs, and that presents an opportunity to capture a large discount on projects that you're entertaining, and to help pay for LL97 compliance. So, you know, the aim of the game with all these different programs is to stack as many together as you can, and to collect the largest dollar value that you can. And New York has a lot of money available for this type of project.
Thank you, Jay. So on that note, I'm actually going to turn it over to Matt now to talk about demand response programs. Before I turn over to Matt, just want to remind everybody, any questions, especially if there's anything on those incentives, we can share out more information later, but feel free to ask any questions in the Q&A section. On that, Matt, feel free to take it away.
Yeah, Eric, thanks so much. And following me, is that going to be Ecosave, or is that going to be Tagup?
I'll be following you.
Okay, great, excellent, perfect. You can do the next slide, thanks. Good afternoon, everybody. Before I get started, I want to thank everybody for joining today, and Tagup for hosting. It's really an honor to be part of this. I'd like to start by saying that one of the biggest misconceptions in the New York market is that it's going to cost building owners out of pocket money to comply with Local Law 97. This simply is just not true. My partners on this webinar today, Tagup and Ecosave, have developed energy efficiency and decarbonization measures that allow for the inefficiencies of the building to pay for these upgrades with $0 cash outlay. Brilliant stuff. As for CPower and demand response market, we simply deliver annual revenue to building owners to improve net operating income and fund their decarbonization measures and Local Law 97 compliance roadmap through demand response participation. By way of a quick reintroduction, my name is Matt McHugh. I am the account executive for CPower, focused on providing demand response and demand-side energy management services to the New York State market, with a deeper focus on the 5 boroughs of New York City, i.e. Local Law 97 territory. As you can see on this brag slide, CPower is the patriarch of demand response, being in business for over 20 years and managing over 6.3 gigawatts of electricity across 2,400 clients nationwide. CPower is active in all deregulated markets throughout the United States, turning those 2,400 clients into virtual power plants to provide resiliency to the grid, preventing brownouts and blackouts, and earning those clients over $1 billion since 2015. Lastly, on this slide, I'd like to draw your attention to the lower right-hand side, where just last year, CPower was responsible for having our clients avoid 286,000 metric tons of carbon. By participating in demand response, buildings are shedding load when the grid is peaking and it's most carbon intensive. And we calculate the carbon avoidance for our clients to use those metrics into their ESG and sustainability reporting. Next slide, please, Eric. So carbon avoidance, is just part of the robust offerings that demand response delivers but what really attracted me to CPower is the revenue builders can earn participating in demand response programs. New York City is the most lucrative demand response market in the nation. As you can see here, 1 megawatt of electricity is currently worth $258,000 in Zone J, which is Manhattan and the outer boroughs. This revenue can be used to help improve net operating income for building owners and leverage revenue for decarbonization measures, i.e. Local Law 97 compliance. Now, can one building do a megawatt? That's few and far between, but a portfolio can do a megawatt. And if we're looking at maybe possibly a building doing curtailment in the market, we're seeing an average of about, 100 kW. So, just do the simple division there, looking at about $25,000 annually in demand response revenue just by participating in demand response in New York City. Next slide, please. Now, what does it look like to participate in demand response? You'll see on the left-hand side the SCR program, Special Case Resources. This is the most benign the New York City program has to offer. As summer event hasn't been called since 2018, and all that is required is a 1-hour test for the summer season and a 1-hour test for the winter season. If an event is to be called, a building is given 21 notice beforehand, and building and 21 hours beforehand, and then 2 hours prior to the event itself. Buildings are calculated on the 4 best hours of a 6-hour window in that SCR event. But again, winter hasn't been called since 2013, and summer SCR program hasn't been called since 2018. So if you have a megawatt of energy to curtail in Zone J, Manhattan, the outer boroughs, you will make $101,000 for a 1-hour test in the summer and a 1-hour test in the winter. The SCR program is a capacity-based program and will be called when the grid is in threat of overusing 92% of its energy. There's also the DSAS program here, the Demand Side Ancillary Services Program. Not many in New York City are going to respond, are going to be able to be a part of this program. This is another NYC program that focuses on frequency of the grid, and who really participates this are large energy users upstate, mainly crypto clients who have servers that can actually ramp down in 10-minute increments or 20-minute increments and ramp back up in 10-minute increments and 20-minute increments to actually help provide resiliency and frequency back to the grid. Next slide, please. Similar to the New York ISO SCR program, Con Ed has its own capacity-based program called the CSRP program. This is the program on the left. This program is actually the most active program of them all. It was only called once in 2023, but it was called 6 times in 2022. So that gives you kind of what a light year could be and what a heavy year could be for the CSRP program. CSRP, like SCR program, is given 21 hours notice in advance and then our 2-hour notice prior to the day of the event. And events are 4 hours, and the building is actually paid for its performance. To the right of that is the DLRP program. DLRP is another Con Ed program, but this program is leveraged for emergency only. Say, for example, a substation going down, or a car hits a telephone pole and wires go down, things of that nature. This also does not get called that often, but if it does get called, the building is only given a 2-hour notice, which is reflective of the emergency-based nature of the program. Again, this does not get called often. It's only been called once in my portfolio over the past 4 years, and that was in Jamaica, Queens. The only requirement is a 2-hour test and a 2-hour notice prior to the event itself. So again, what I just spoke to here, what's very important is that whether an event happens or not, you will be paid on that revenue for participating in demand response and rolling your capacity into the market, which is a great way for buildings to earn revenue that wasn't there to improve net operating income. And as it relates to this presentation, pay for decarbonization measures and local law 97 compliance. Next slide, please. So who's participating? We're seeing a tremendous boom in demand response participation. Just take a look at the 2021 to 2020 year growth, nearly tripling in CSRP and DLRP. Incredible growth in demand response. And that's because buildings are becoming smarter, buildings are becoming more controllable, and buildings are becoming more flexible. And by the way, the market's really starting to see that, yes, local law 97 is coming down the pipeline here, and we're going to start needing revenue streams to really help pay for these decarbonization measures. So one other thing to note here, yes, we're seeing a major uptick in the actual buildings that are coming on, going from 6,000 to 15,000 year over year. But we'll also notice as well, if you go up to the top, the megawatts are not increasing that much. We're only seeing a 9% increase and a 10% increase, which does mean critical mass is coming in, but that critical mass is coming in by way of smaller buildings. We're starting to see a big uptick in the Class B territory, buildings over 50,000 square feet to 125,000 square feet that traditionally didn't do demand response. And a lot of residential buildings are coming in too. So this is not a situation where it's only going to be your big Class A buildings that are going to participate in demand response. That couldn't be further from the truth. It's now demand response for all, based on just, again, buildings getting smarter and the grid getting smarter. Now, the reason why it's very important that these megawatts increase into the market, next slide, please. You'll see that there is currently a 446 megawatt shortfall in the New York City area for peak. That is a big peak. So we basically need to double our megawatt production in resiliency to assure that those peak gets met, and the 2 peaker plants that were part of the phase out can actually be phased out. Right now, those can't be phased out. So therefore, those peaker plants still need to stay, in New York City, providing brown energy during peak days. But if we can get the resiliency in, more buildings participating, more megawatts into the market for demand response, we can actually take those peaker plants out of the market. So this is very clear indication. There's no clean energy transition without a resilient energy transition. Next slide, please. Now, why the boom, you ask? We really have Con Ed to thank for this. They've just completed a $2 billion rollout of the smart AMI meters from Westchester through New York City and all buildings over 25,000 square feet. Again, another big reason why we're seeing that major uptick in smaller buildings participating in demand response. These smart meters allow for a plug and play in demand response and provide 5-minute interval data to shape buildings' load profiles, calculate demand response program baselines, and provide real-time performance of demand response events. Before AMI meters, new meters needed to be purchased by the smaller buildings, and it just wasn't economically feasible to do so. So really what's happening here is these Con Ed meters, AMI meters, are creating the smart grid to plug in with smart meters, i.e. making it a smart city altogether. Next slide, please. So on the note of smart buildings leveraging demand response revenue for decarbonization measures, I think this is a great example of that. CPower has developed our BMS as a service solution, where we're able to simply put a light BMS system into buildings that just haven't had one before. And we're able to actually pay for that by way of demand response revenues. How we do that is install a gateway into the building or multiple gateways into a building and swap out these old analog meters with these new smart thermostats, which really adds a nice climate tech feel to a building at $0 cash outlay. These smart meters allow buildings to participate in demand response autonomously, and the demand response revenues earned pay off the BMS system in 2 to 3 years max. Once those BMS systems are paid off in 2 to 3 years, for those additional years, that's nothing but gravy and demand response revenue moving forward annually for these buildings that once couldn't participate in demand response. Staying on the slide, what CPower does is CPower integrates our internal dispatch system via an open API with these smart thermostats to automate that demand response. So this is really where automated demand response started to take hold and smart cities are really starting to thrive. Next slide, please. On this next slide is actually a client of ours. This is 230 West 39th Street, an event in action for one of our clients. This graphic is a digitization of one of the building's package units running throughout the day. When the demand response event happens, we pre-cool the building and then raise the temperature pet points and turn off one compressor to drop the kW needed to reach 230 West 39th Street's demand response goals. So this is a clear indication here of a building running as is, the pre-cooling starting to happen, and then when that blue line really kind of spikes up like that, that's when the event gets called. That's a CSRP event from 2 to 6 o'clock over the course of 4 hours. And you can actually see that curtailment by way of this digitization, all autonomously for one of the packages at 230 West 39th Street. They have about 10 package units that these are all installed in, and we're currently controlling about 37 kW worth of load within this building, which equates to about $10,000 annually for the building. Now, if you can do the next slide. So this is kind of the inverse of that, right? So you're looking at it from a package unit, but this is actually the performance of that demand response and the demand response results of it of 230 West 39th Street. So without anybody in the building touching anything, without supers running around turning anything off, this all had it happened automatically by way of smart thermostat and gateway, and demand response sequences programmed into these smart thermostats to help hit their 37 kW curtailment goal. And this has been happening over for the past 2 years with this building. And we've been receiving very, very little complaints, if at all, based on this climate tech is also providing us the data to say that, okay, yes, a compressor went down. Yes, the temperature set points went up, but because of that pre-cooling, we're actually able to keep those temperature set points at the agreeable 72 degrees of those spaces. So no one even knows anymore. Year one, we really had to get a lot of stakeholder engagement, let people know what was happening, let them know that their package units were going to start changing, going on and off. That kind of freaked them out a little bit, but once they got used to that after a year two, there was no issue at all. Next slide, please. Another beautiful thing about this BMS as a service solution, not only does it provide demand response revenues, but it also provides energy efficiency as well. This is also with 230 West 39th Street, where they were originally in A. We didn't think this was actually going to do much, just putting these smart thermostats in. But what they did do, we actually saw a big jump in their Energy Star score by 4 points. This owner loves his A. He's keeping his A, and it's only getting stronger, based on the future proofing that we're providing by way of this BMS system. So really, how I like to kind of end with this alone is that through energy efficiency, we're seeing carbon efficiency, and we're also seeing local law 97 compliance. Next slide, please. So how do you start? Simply, we don't charge at all. The only thing we'll take money from is if we actually do enroll the building into demand response. We take a small portion of the split. If you took a look at my slide that did have those revenue numbers, I actually put the revenue split in there, where 80% of that split, that $250,000, is going to the client, and we simply take 20% of that. If it doesn't work out, if you don't decide not to move forward with demand response, we charge you nothing. It's nothing but sweat equity on our side. How you get started is just simply sign a letter of authorization. That letter of authorization is going to give us interval data. We shape the load profile of the building, build the building's baselines, and then my engineering team will have a conversation with the building's engineers and operating staff to see how the building can curtail. Are they amenable for the BMS as a service solution? And see what we can do in terms of curtailment for that specific building. If it's a go, we agree upon that KW, the client agrees upon that KW that gets enrolled, and we roll that to participate in the market. We've got good timing here for early enrollment. Early enrollment is going to be April 1 for the New York ISO SCR program and CSRP and DLRP program. But if we miss that April 1 deadline, we have the late enrollment, which is May 1. So we still have plenty of time to get engaged. This completes my presentation. Looking forward to questions at the end of the presentation. And now I'm actually going to hand it over to the Tagup team so they can talk about their HVAC optimization product. Thanks, everyone.
Thank you, Matt. And yes, please feel free to, if you have any questions from Matt's session, just go ahead and put in the Q&A. We can get those at the end as we wrap up in probably about another 20 minutes from now. So I'll be going next over our HVAC optimization technology. Once again, my name is Eric O'Neill, and really our technology works with building automation systems or building management systems like Matt was talking about in his presentation. Jay at Ecosave will also talk about their BMS offering, which is a little bit more advanced. They offer a automated logic control solution. So I don't want to take away too much from Jay, but just to explain how our technology works. If you look at the right side here of our diagram, we are sitting on top of a building automation system or management system, as well as any HVAC equipment that's on site. We work best with buildings that have large central chiller plants or boiler plants, but have the ability to learn, as long as certain data points are available, to learn from different types of equipment and recommend control changes that will lead to cost savings and respective carbon emissions. One of our key considerations, something Matt talked about during his presentation with the demand response, is we never want to impact tenant comfort. So any changes that we make, we're making so that there's still the same level of heating or cooling load delivered to the building. And really, we're just trying to operate the equipment as best as possible, empowered with data and using our machine learning models. So as we pull out that data, we typically sample it about every 15 minutes. We'll send it either directly through a software integration, or if that's not possible, depending on the building automation system on site, we'll install a Tagup Edge Gateway, which is a industrial computer that will allow us to send out the points to our cloud servers where the machine learning models operate, and then also send back, write directly back to the building automation system with any changes. We run these models every 15 minutes, extracting operating data from the equipment, combine that with weather conditions as well as utility rates, understanding how the cost of electricity changes throughout the day, water, gas, and also looking at any peak demand charges that'll be incurred throughout the day, looking to operate the equipment at the lowest possible cost while still meeting the given set points within the building. Our technologies can provide up to 30% cost savings. Traditionally, with large central plants, we see around 17 to 22% our average savings. And there are utility rebates available. So Con Edison's the most common utility provider we come across from in the New York City market. They pay out a 35-cent per kilowatt reduced by our technology, or $2 per therm reduced, which can be a pretty significant rebate paid back to the client after a year deployment. And we do provide visibility in not only the energy consumption that's done by the different HVAC equipment, but also the carbon emissions that comes from that energy consumed by the HVAC systems. So how we work is we initially integrate with the building automation or building management system. We don't shut down any equipment. We're just a non-invasive integration. So we either do that via the piece of hardware I showed, or we can do it with a straight software integration. Just depends on the building automation system on site. We will then evaluate the equipment and understand how the system performs. We can do this in two different ways. If the site has historical data available, we can run machine learning models before we even deploy, understanding how the equipment's controlled at a baseline, and then start figuring out how we can make changes to lower that cost. If that historical data is not available, which I'd say in about 80% of buildings that's the case, we will just have an observation period that can be anywhere from 2 weeks to 3 months, depending on how the weather varies during that time, and also our ability to change set points during that time, depending on the site's preference, just so we can understand how the equipment operates and changes with certain control changes. We'll then start deploying our recommendations. So we do this in a manner that we automatically write back to the building automation system, implementing the changes autonomously. This doesn't require any operators in the loop. The operators will have visibility to see the different set point changes that we're making, and also have the ability to toggle it off if for any reason they have concerns about mean comfort for the building. After we're deployed, we continually retrain our machine learning models. So these are models that the more data they have, the more system performance they're able to observe, the stronger they'll be, where they can continually refine and understand where there's different opportunities to further create savings for the client and reduce energy consumption and carbon emissions through the HVAC systems. So this is a chart on the right side as our minimum data resolutions every 15 minutes. That's with Con Edison, they provide the electricity interval data in that as well. We are going to stream that operating data to the cloud, combine that with any utility and weather data that's coming from different sources. The machine learning models will determine the ideal settings. We'll implement those ideal settings. On average, we're only changing control changes or making control changes about once every hour, unless there's a drastic change in weather and or building load. And we'll continue to run that cycle as weather and building load change, which is going to lead to reduced energy and water consumption. There's a number of different set point optimization or staging and scheduling optimization techniques that we can deploy at certain buildings. Our approach is to find one or two control changes we can make to start out. We like to keep the scope small so we can have a small number of data points that we need to rely on through the equipment. We find that sensor data through the building automation system isn't always reliable. So we want to have a reliable system that will be able to continually operate and not fail if there's any different equipment issues. And as I said, when we see systems like chillers or boilers in central plants is where we're typically seeing the highest amount of savings. Sites with package units or heat pumps, variable refrigerant flow systems, there are savings possible, just not as high a percent, because typically the piece of equipment are more efficient and also have more ability to easily turn off or on because they serve smaller spaces. In terms of our measurement and verification process, I like to go over this. I think one thing I haven't mentioned is how we price. We collect a portion of savings that we're generating for our clients. So we prefer to operate with no upfront costs. If there is data points missing, we can meter those points and look at ways of getting the data we need. Depending on how much we have to invest up front, depends that leads into what collection of savings or what percentage of savings we're collecting. We are looking at first establishing the baseline, which is what we do during that observation and modeling period or using historical data. That baseline is crucial because that allows us to then see any changes we make, how we've operated the equipment more efficiently, and understanding the difference for cost for operating at our recommendations compared to the baseline. The difference between those two numbers is our savings number. We provide a dashboard where that number is updated in real time, as well as we send reports, as you can see over here on the right side, that shows how those savings are affected. Since we use machine learning models, this is very helpful for us to be able to continually provide the measurement and verification. So we use that to map out the cost to operate the HVAC systems, and we do meet ASHRAE guidelines for a calibrated model. So that's 5%, within 5% for monthly predictive data and within 10% for hourly data. And before I turn it over to Ecosave, just to give you an idea, Jay and I are both local to Philadelphia, but are in the New York market often. One of the first projects we worked on here in the Philadelphia area was the Constitution Health Plaza. Jay was nice enough to provide us a strong quote there, and we were able to provide about 17% operating costs in the condenser water loop at the Constitution Health Plaza, which is a medical office building in the Philadelphia area. So I'm going to go ahead and turn it over to Jay. Thank you, everybody, for listening to my portion of the presentation. And once again, please put any questions in the Q&A section. Take it away, Jay.
Thanks, Eric, and thank you, Matt. So, yeah, I'm going to be talking about how to get to LL97 compliance without huge capital outlays, as there are a number of different options available to kind of chart that pathway. And I'll cover Ecosave's offering specifically. So if we can go to the next slide. So if you have LL97 compliance issues, maybe you go to the accelerator website that Eric linked and you put in your building details and you see that you're not in compliance, or if you have energy usage reduction goals to increase your operating income or decrease your net operating expenses in a building. If you have capital equipment like chillers, boilers, HVAC systems, building monitoring systems, and you need to replace them or install them and you don't have any budget to do so, or if you have problem child equipment that just incurs a lot of maintenance costs, Ecosave can help. So if we go to the next slide. So we can help with a turnkey LL97 compliance and management. We understand that often these programs and incentives represent an administrative burden on a building or a company, so we can help with that. We can fully fund energy reduction or capital equipment upgrades with no upfront investment from our customers. And where you still need to provide additional emissions reduction, we can procure carbon credits and RECs and do things like virtual PPAs for RNG, lots of different options to get you to your net zero goal, your long-term goals. So how do we do that? We ultimately deploy teams of engineers who go out and walk the buildings, study the buildings, and do comprehensive surveys to understand how a building is operating. And then those engineers develop a custom solution that includes a suite of different energy conservation measures and capital upgrades that are specific to your needs. And finally, we put together a proposal that includes our energy savings guarantee, the scope of work for the measures included in the project, and a fixed price cost. And typically, we package projects and develop projects that provide savings that exceed the ongoing fees that we charge, such that we can provide cash flow positivity and free up operating cash flow for you to spend on whatever you want. Next slide, please. So as part of this offering, we wanted to just summarize what you get. Obviously, you get a chance to implement Tagup, which I thoroughly recommend. You get a free audit grade assessment where we're evaluating large capital upgrades and engineering surveys, things like that. We provide the non-committal proposal with an energy savings guarantee, which you can make a decision on completely at your discretion. You get new equipment upgrades, as well as repair and refurbishment and optimization of older equipment and systems that still have useful lifespan. You get a whole bunch of other energy conservation measures that can help pay for longer payback items in your project. And you get a maintenance and repair partner that takes care of your new equipment to ensure that it's maintained, that it performs from an energy perspective, and that it's not going to incur significant costs down the line. And lastly, you get turnkey incentive and LO97 management, where you don't really have to deploy your own resources to managing incentives. You don't have to take on the risk of not getting the incentive, and you don't have to ultimately be fined by the LO97 program. Next slide. So for the Ecosave offering, we really deal with measured performance for LO97 and the incentive programs that can benefit you. They all really deal with a requirement to demonstrate and prove the emissions and energy reduction that comes with the projects that we deliver. And to do that, to provide that measured performance, we connect to your utility data, we connect to the system and equipment data, we review operational trends and things like that for the life of the contract. And we use that analysis to compile an annual measurement and verification of savings and emissions reduction report, which we put together following the International Protocol for Measurement and Verification, IPMVP is the acronym. And often our customers also use that report to fulfill their own corporate sustainability goals, where they can showcase the benefits of the projects and the emissions reduction that they're getting. The energy reduction guarantee that I mentioned is really just that if we don't deliver on an annual basis the energy savings that we proposed, we will write you a check for the shortfall. And that means that Ecosave as a partner has skin in the game, and we don't just install the project and walk away from it. We have to maintain performance of the systems that we install. And energy efficiency and high performance buildings, they can lose efficiency and savings over time. And you always have to be putting the savings back. It's really death by 1,000 cuts. So we are very vested in working continually to ensure that our projects perform as proposed for the life of our contract. And then lastly, we're very aligned with the New York incentive programs that we reviewed at the outset of the presentation. And for us, the more money that we can capture and secure for our projects, the better the project financials look. And thus we provide more compelling projects to our prospects and customers as a result. So I'll talk a little bit more about that in a subsequent slide. But like I said, the name of the game is really to stack as many incentive dollars as you can into any project that you're considering. Next slide. So we wanted to show the depth of the types of projects that we're talking about. And this is a project for the Jewish Federation. And just to summarize the results, there was over $3 million in capital upgrades that we funded at no upfront cost from the customer, using our own funding as well as the incentives and grants that come from the utilities and state governments. The project delivers over $300,000 in annual savings over a service contract of 15 years. And compared to the baseline, the building is now consuming 50% less in whole building energy. And just to quickly run through the scope of work that went into this result, we installed a rooftop solar array. We installed an on-site power generation system, a combined heat and power, where the electricity produced by that system is consumed on site, and the waste heat is going to heat their pools and their health and wellness spa and their domestic hot water. We installed new high efficiency condensing boilers to replace end-of-life conventional efficiency boilers. Similar story for the replacement of old rooftop units with new high efficiency models. We did a comprehensive LED lighting upgrade across the entire campus. And we installed a new building automation system such to create a scenario where each of these disparate kind of heating and cooling systems are not fighting each other, where one system's providing cooling and another system's providing heating, and they're working against each other. So we've eliminated energy waste, which is a great result. We did a whole bunch of water source heat pumps, and we also have an energy management system we call Ecosave Watch, which we use to monitor and analyze and review the operation of the building to ensure that it's performing as proposed. And lastly, we provide comprehensive mechanical and building controls maintenance services so that we know that all of the new systems and equipment are being maintained correctly, that the service technicians are doing their job, and that we can retain the high performance operation into the future. Next slide. So on the topic of emissions reduction, we wanted to provide a few of our demonstrated results. And we worked with a New York aged care facility and did several phases of projects. And the outcome of those projects is that we're saving over $600,000 in cost savings from energy reduction each year, over 4 million pounds of annual CO2 reduction. And on this project, we've secured over $700,000 in incentives from Con Ed and NYC. We have another project in New York that we work with, which is a Manhattan Community Center. And that project scope delivers over $50,000 of annual cost reduction, over 800,000 pounds of annual CO2 reduction, and has secured over $300,000 in incentives from Con Ed and NYC. And then we also have a project in Coney Island where we've secured $4.5 million in total incentives from Con Ed and NYC for a New York-based geothermal project, which is very exciting. So we wanted to showcase these different New York projects to really convey how we identify and secure all of the utility and government grant money that's available, and then we package it into a project to make the project pay for itself. Slide, please. So as we wrap up our presentation and do some Q&A, we just wanted to recap your priorities. We understand that you want to implement Tagup and C-Power. You want to reduce your energy costs, replace aging equipment, avoid capital expenditure, and achieve sustainability goals. And it seems that can be quite challenging. And I'm not here to say that it's easy, but the group that is assembled in this webinar can really help you do that. And our mission is decarbonization and LL97 compliance. So yeah, we'd love to help you